All right, here we go. So from way back when we were doing transformations, when you had the absolute value equation, the graph, we had the up, down, left, right, compression, stretch, reflecting across the x-axis. And all of those things will transfer over into any kind of function, any kind of graph. So I just want to remind you a little bit about that, and then we'll apply it. We're not actually going to do the graphs, but just describe what would happen with the graphs, and then write a basic equation for the cubics if you know it's a cubic ahead of time. Okay, so to tell if it went up or down, remember there was a plus or minus of a number on the outside. You'll see an example shortly. Left or right was subtract or add. This is the one that always felt backwards to you. The compression was when you multiply by a number less than 1. So fractions and decimals that are less than 1. The stretches were when you multiplied by a number greater than 1. And then if there happened to be a negative thrown in the front, that was when it reflected across the axis. In other words, it turned it upside down. So you can jot those down. Those who have been here all year, it's like we really seriously spent a lot of time on this. So when you see it, you'll be like, oh yeah, that thing, I hope. And if it's brand new to you, hopefully you'll pick up on it quick, because it's not, it's going to be just a descriptor and not really something that we're going too deep into. Okay. Here we go. I'm going to pause for a second, pause the recording. All right, if you look at the upper right of your sheet, you have this. For those of you that remember about parent functions, you always had one function, and then the other things came from that one basic function. Do you remember, even in this chapter, when we did the things to the third power, what was the end behavior? What was it?
Down, up.
Down and up, okay? So down and up. So this is the same basic thing, except for if it got flipped around, then it would be up and down. So we have all of those things to consider as well. But then when you've got these parentheses in here, that means you're modifying the x part. So you're modifying the left and right. This part is going to modify the up and down. This part is going to tell you whether it's stretched or compressed. And then this part is going to tell you whether it is reflected around the x-axis or whether it's just normal.
Can you say it again?
So, well, let's go through the pieces. What does the -5 tell you? Does anybody know?
Down,
Tells you that we're going down 5. Okay, so on here, we usually start with the furthest thing away. That means 5 units down. Okay? The part right here that's in the parentheses is going to tell you whether it's going to move right or left. This is the one that always seems a little backwards. This one would be left 2.
So it would be 5 units down because it's negative down, -5, right?
Right. And this would be 2 units left because -2 plus 2 gives you 0. So that's basically the simple explanation as far as why it's 2 units left instead of 2 units, right?
Yeah, is that don't confuse it
And
more.
then the -3 means compression, right? Or does that mean that
Forget the negative for a second. Just look at the number without the sign. So if that number is bigger than 1, it means stretch. If it's smaller than 1, it means compression. So this is a stretch. So it would stretch.
What do you mean stretch or compression again?
Stretch means that since you're multiplying it by 3, the numbers are going to be like pulled further up. So if you had a graph, it would be like pulled this way. Stretch vertically. Yep. Compression would be smushed
Oh, okay.
vertically.
So both of them, it's
Yeah.
above vertically.
Vertically. What's happening vertically.
but
Yep.
it's a negative.
But it's a negative, so that means that it reflects across the x-axis. So it turns upside down. So instead of being down and up, this one will be up and down.
So, if you want to do compression, it's either 1 or 0?
If you don't want to do compression, it would be a number that's between 0 and 1. So like 1/5 or 0.9 or 1/8 or even -3/5. Any number that's between 0 and 1 would be a compression.
So basically the parent is now flipped upside down.
Parents flipped upside down, it's moved to the left 2 and down 5. And so that's what's happening with that.
Thanks for that.
Yep.
So
So here the 8 would be what way?
To the right.
The 8 would be
Huh?
not to the right. The
Wait.
one on the outside tells you whether it's
you're talking about
going
this.
up or down.
Oh.
It's going up.
Up 8 units up.
The 3 is to the right.
This would be to the right,
To the
3,
right.
you're right. hmm
3 units to the right.
So 3 units to the right because of this. It would take the initial parent that would be down and then up, and it would move the whole thing right 3, up 8, and with this stretcher compress it.
Right.
Compress it because every one of the values would be multiplied by 1/5, which would swoosh it down. Okay, so vertical compression
Oh, so the
of
difference,
1/5.
the difference between vertical, because I didn't study that, that's why I'm asking.
Say what?
Vertical strat and vertical compression, the difference is one is less than 1 and 1 is greater than 1, right?
Correct.
Okay,
Exactly.
just asking.
Exactly. Less than 1 or greater than 1. Yeah, we spent a long time with this. I know you weren't here for that, but the,
No, yeah.
the scriptures hopefully are something that you can pick
No,
up.
yeah,
on
I
pretty
just
easily.
know because I studied like up, down,
Mhm.
right, left, but
Yes.
just compression I haven't studied.
Oh, okay,
Like
you hadn't studied.
reflects across x-axis or y-axis. I studied that. Just this.
Okay, just
I
not the
didn't do
stretcher compression.
Yeah.
Okay, cool.
Like a review or something?
It's kind of review, except for it's not the absolute value one, now it's to the third power. Honestly, this will work with any parent function. So if you have a basic function and then you put these modifiers in it, it just means take that graph that you know what it looks like and move it.
So
Up,
instead of
down,
it
left,
being
right.
squared, it's just to the third power.
Right, so it's to the third power, it'll make a different parent, which I have by at the end of the lesson, a very basic picture of that. All right, so this one, if we're trying to find the zeros, we're back to our calculator. Actually, we do have a calculator. I forgot we do have a calculator on this. So get a calculator, make sure you've got that. Thank you very much, calculator distributor guy. Okay. Okay, so since we were doing the thing with the plots on, please make sure that all your plots are off for this part. So some of yours may have plots on. You need to make sure that they are off.
How can I take it off and how can I take on again?
Okay, so if you push the Y equals button, the quickest way to turn them off, if you push the Y equals button and any of them are colored in the top, you would go up there and you would hit enter on it and you would make it so that it looks like this, so they're all nice and
Okay,
clear.
but if I want to select one like this and just enter,
Yeah, and then you turn it on, that's the way to turn it on, you need to turn it off.
so now I'm gonna turn it off.
Off,
clicking
yeah.
it.
Yeah, that's like a quick shortcut to turning off and turning on. So all of your plots should be off. We want to put this into your calculator, so put in parentheses, x minus 3, the x is up here, x minus 3 to the third power, plus 1.
And
Okay.
then
And what are we using? We're finding,
We're gonna do zoom 6, we're gonna find the zeros.
oh,
What we're expecting from these is we're expecting it only to hit the graph at one place. Okay, look and see what's happened to it, okay? Our parent, if you remember, our parent, we're expecting to start down and end up. And it has this basic shape for a cubic. I don't know if you remember that from the day we did like the million graphs. Okay, so this is our basic shape. It went down and up. It crosses the x-axis only once. So this will be our intercept, so we can second calc 0. And our left bound, we're just going to move actually to the right because it always starts on the 0. So we want the left bound to be kind of here to the left of the answer.
That's all we have to do.
And hit enter, and then go to the right of the answer, which means go past it to the right, and hit enter, and you can go close, and hit enter, and it says 2. It actually looked like it was 2 on this one, but I was just double checking. So x equals 2 is our 0, or where the number that will give us a 0 on this.
So can you just write like x equals 2 instead of
X equals 2, yep, and that's it, that's the answer.
Oh,
Yep.
okay.
Because what you want to know is just like find the zeros.
Yep, find the zeros. On this particular one, you could have multiplied it out and done all of the factoring and all that stuff, but there's not a point to doing that when you're allowed to use the calculator. We're just expecting one actual 0 to show up when we have these third power graphs, because they've just moved somewhere on it. They're only going to cross the x-axis one time. Theoretically, there would be a couple of other hidden roots to it, but we're not even worried about them. We just want to get the real 0, which would be the one place where it crosses over here. All right, this one, let's try this one out. Do the exact same thing. You practice. So y equals x minus 5 cubed. I want everybody practicing, please. Okay, you're watching. Gotcha. So y equals, let's practice the other one. X, you can use your arrows even just to modify it. X minus 5 cubed plus, or minus 8. Minus 8. Try zoom 6. Okay. Interestingly, think about what it's doing here. It moved right 5 and down 8, so it makes sense that the whole thing is like down here. But over here, it looks like it's at about 7 or 8. So let's second calc, just verify it, 0. Enter. Use my arrow keys. Hopefully I'm not dragging a calculator all over the world. So much tapping. There it comes. Enter, left bound, guessed it. Enter, right bound, and then guess. And it came out as 7. So x is 7. Okay, so nothing new on that. We're just looking for the 1, 0. So not even like left bound, right bound, all over the place. It's just the one answer for those. Okay. So that's pretty nice. Only expecting there to be 1. Okay. Yes? No? All right. And if anybody needs more help in a minute, I can certainly just stop it. But we're going to go on, and people at home, hopefully you are doing that. Or people who are on the road or wherever you're watching and listening to this. All right. This one is, again, bouncing back to some other things. Oh, this should not be, okay, let me change this. This should be x to the 4th. It should not say x with a subscript of 4. So let's fix this up. There we go. Quartic means that you end up with x to the 4th as one of your, as the first term if you were to multiply everything out. So we want the real zeros, the ones where it crosses the y-axis, to be 2 and -3. Do you remember before how we wrote a function that would have 2 and -3 as the, yes, Anthony?
Would be like x minus 2 and then x plus 3.
Good, x minus 2, x plus 3. The only difference here is that we need to make sure that it's to the 4th power. So we're going to square both of them. This is the easiest way to do that. is make each one of those answers with a multiplicity of 2. So x minus 2 squared, x plus 3 squared, all of a sudden, we get x to the 4th. I would have to be careful. I wouldn't be able to do 1 and 3 because I'd end up with some other zeros in there, but 2 and 2 will work if you're going to get a quartic for an answer. Another possibility, now this one's the easiest one, so I'm expecting most of you to just kind of hold on to this one and do that. Another possibility is to have one of these and one of these, x minus 2, x plus 3, and then pick something else to make sure that you've got an imaginary solution for the other two. An imaginary solution. So for example, if I choose x squared plus 5 as the other part, I'm going to have x times x times x squared. I would have a quartic. But with the plus 5, if I were to try to solve it for that, and it could be plus anything, but if I were to try and solve that last piece, I would get an imaginary as part of the answer. So that would be another way that you could find a quartic function with the only real zeros of 2 and negative 3.
You can do any positive number you want to.
Correct. So that would be a second option. Like I say, I'm expecting most of you to just hold on to this one and say, yeah, I'm just going to square both and then be done with it rather than trying to get super creative and putting in another one. But you can if you want to. So option 1 is fine if that's the only one that you want to pay attention to. Because we get a quartic, the only real solutions are these two. Remember, with the quartic, we're expecting that we're going to have a 4 solutions. So here we definitely have the 4 solutions, pardon the fact that it just made it into a, here we go. Didn't want it to be a subscript, I wanted it to be x to the 4. Okay, we are actually almost where we need to go. Okay, except we have these neat little graphs where we need to find equations. Ahead of time, they are rough graphs, but I'm telling you that they're all from the parent function x to the 3rd. This is in general what you see if you were to put in the calculator x to the 3rd. Notice that it goes right through the origin. And it's not a maximum or a minimum, but this is like our key anchor point as far as where things belong. So if that key anchor point moves, but it has the same shape, it's still going to be a cubic. But we could use that up, down, left, right idea in order to make an equation. So this one moved right 1 and up 2. So what would the equation look like? Yeah, go ahead.
Y equals x minus, in the parentheses, x minus 1 parentheses to the 3rd power plus 2.
Good, beautiful. So you're just going to use the ordered pairs. This means right 1. This means up 2. So you would take the graph, even though it's a very rough graph, and just write the equation that goes with it. We could go very much deeper and get a lot more details into it, but in the interest of getting to where I want to get by the end of the year on some other things, I'm just kind of giving you the surface glaze. Okay. This one, somebody different. What would be the equation that goes with this one? Go ahead. Okay. He said y x plus 1 cubed and then a plus 1. Don't forget to put in the cube part. So plus 1 because it went left 1, and plus 1 here because it went up 1. This one went right 3 and up 1. Go ahead.
It will be negative parentheses x subtracted by 3 to cube plus 1.
Yes. Why was there a negative out front? Because it flipped over. So instead of being down and up, this one's up and down. So it flipped it across the axis. It flipped it across the axis and then moved it over 3 and up 1. Okay? All right. That's it for the new material. I'm just going to say this for the people at home. Tomorrow is a work day. Okay, so you would have a day where you don't have new things, but when you come back, you're gonna have a take-home quiz, as I had pointed out. Monday, you're gonna start in on that, so I'll expect all of the homework. I'll expect all of the homework to be turned in on Monday, as I told you. And then we'll do that take-home quiz and then have the test before winter break. The test, as you had seen before you left, will start on Wednesday, and you'll be able to finish it Thursday if you want. That will leave our seniors with enough time to do that before you go on your winter break, but you need to do that before winter break. Bless you. Have a good trip back and a good end of your tournament.